Hello everyone, in this video I will show you how to compute an artificial neuron by hand. Before working on this worksheet, you should watch the lecture video that demos the single neuron simulator. The solution to this worksheet is available online. However, you should solve the problems here by hand before taking a look at the solution sheet. Feel free to download the worksheet, print it out, and follow along on a piece of paper. That's the best way to learn. Here is a typical illustration of neural network models. I want you to circle a neuron, its 3 inputs, and one of its outputs. You can pick something in the middle, and then highlight the 3 inputs that go into this neuron. And then the output that it contributes to. Exactly how does a neuron work? Let's put it under the microscope, and you will see that within this neuron, it's actually just a bunch of math calculations. I want you to compute a single neuron using record 2 from the single neuron simulator. Let's return to the single neuron simulator. Over here, you can see that we have 16 records of data, and record 2 is a customer with age 1, gender 0, and income 1. So let's come back here and put in this customer's data, 1, 0, 1. And I want you to use equal weights of 1, 1, and 1 here, and 0 bias. Okay, so with these records, these data already filled out, now we can fill in this weighted sum equation over here. So it's bias plus the feature multiplied by its weights, the feature gender multiplied by its weight, and then the feature income multiplied by its weight. And we can add these numbers up. So this is a 1, this is a 0, this is a 1. And because bias is a 0, we have a total of 2. And 2 is what we call the activation value. We will run this activation value through this activation function, and we're using the step function over here, which outputs 1 if this activation value is greater than 0, or we will return 0 otherwise. Because 2 is a positive number, and so we will output 1. In other words, this model predicts that record number 2's loan is going to be approved. But is that correct or not? Let's return to our single neuron simulator and take a look at record 2's data. And in this data set, because it's a historical data set, we actually know that record 2's loan was not approved. The approval class is 0, and so when we go back to the worksheet, we should write down actual is 0, and because approved is 1, these two numbers are different, the prediction is an error. Now we're going to compute another single neuron, and we're going to call it neuron 2 using the same record, which is 1, 0, 1, with the weights of 0, 1, negative 1, and a bias of negative 1. Now again, we copy these numbers here. We'll calculate the weighted sum. As you can see, this is a 0, so this zeroes out, this zeroes out. We have negative 1 plus negative 1, or the total of negative 2. And when we run it through the step function, this will give us a 0 because it's a negative value. Now again, because the actual class for record 2 is 0, this time it is a correct prediction. Now that we have computed 2 neurons, we can put them together into a neural network. Again, we're going to use record 2's data 1, 0, 1, and we are going to copy the 2 neurons that we have trained previously over here. So this is 0, and then 1, 1, and hold on a second. No, this is not a 1. Should be 1, 1, and 1. So these are the 3 weights that go into neuron 1, and the 3 weights that go into neuron 2 is 0, 1, and -1. And the bias for the second neuron is -1. And remember, for the first neuron, we computed 1. You know, the sum was a 2, and 2 was turned into a 1 after the activation function. And for the second neuron, we computed 0, and the total was -2, and after the step function, it was turned into a 0. And then we're going to use 2 as the weight from neuron 1 to neuron 3, and then -2 as the weight from neuron 2 to neuron 3. Here, we're going to do a weighted sum. Oh, so we also need to use -3 as the bias. So the weighted sum here is 1 times 2 plus 0 times -2, and then plus this bias, which is -3. Now 0 zeros out everything, so this is 2 minus 3, or -1. Now -1, we go through the step function again, and the step function will turn -1 into a 0. And again, because the actual is a 0, the prediction again is correct. When the prediction is incorrect, how would you change the weights to help the neurons make a correct prediction the next time? You will have to adjust the weights somehow, and you have to adjust them in a direction such that the total will go towards a correct prediction. Now, because the more neurons we have, the more weights we have to adjust, and perhaps some of them have to go up, some of them have to go down, and the combination of exactly how these weights should be adjusted can be quite complex, and that really is the million-dollar question for which innovations in AI training had to occur.